We are going to have a chat about these magical, amazing things called square numbers and try and find out a little bit about what we mean by a square number. So if I took the number 3, I could represent it visually like this, couldn't I? Just like 3 blocks or 3 little squares next to each other. But if I took 3 lots of 3 and pile them on top of each other, I've got this image here. I've got 3 rows and 3 columns. I could say I've got 3 lots of 3, or 3 times 3 blocks. So 3 times 3, 3 down each side. It's the square because I've got the same length on each side. So we'd say that 3 times 3 equals 9. It's a square number, because if you have a look at this visually, you can see it makes up a square. It's the same around each side, 3 and 3 and 3 and 3. There's 9 of them all up, 9 squares that make that up. So 9 is a square number because 3 times 3 gives me 9, which I can draw as a square. We write it like this: 3 times 3 equals 3 with a little 2 up the top in what we call the index. So 3 with a little 2 up the top, sort of up and to the right hand side. And the way we say that is 3 squared. So if we see 3 with a little 2 up the top there, we'd say, well, it's 3 squared. And what that means is just simply 3 multiplied by itself, 3 times 3. Here are some other examples of some square numbers. 1 times 1, I write that as 1 squared. Now 1 times 1, if I've got one lot of 1, and you can check this with your calculator if you need to, it's just 1. So 1 is a square number. It would just be 1 square on its own. 2 times 2, I can write as 2 squared. And 2 times 2 we know is 4. We've already done the 3s, let's jump to the 4s. 4 times 4 equals 4 squared, which is 16. So, let's do one more. 5 times 5 equals 5 squared, which is 25. So these numbers here, 1, 4, 9, 16, and 25, we say they are square numbers because I've got 1 times 1, 2 times 2, etc., etc. Okay, and I could visually check that. If I did my 5 times 5, I could do 5 squares, right, 5 across by 5 up. Okay, and I know that that's going to give me 25 because 5 lots of 5 is 25. So I would say 25 is a square number. I could draw it visually as a square. What about undoing a square number? Well, we say the opposite, and the fancy mathematical word we use for opposite is the word inverse. So the opposite, or the inverse, of squaring a number is square rooting, right? Bringing it back to its original 2 numbers. So let's look at an example. Here is the symbol that we use for square rooting. It's like a tick, a big tick with a lid on it. Okay, so I've got a tick with a roof, and inside that I put my number. So if I wanted to know the square root of 25, so what number, when I multiply it by itself, gives me 25? Now this number needs to be the same. Okay, something times something, but the number in both of these spaces has to be the same number. Well, I can see down here I had 5 times 5 gave me my 25. Okay, so I'd say the square root of 25 equals 5. Like I undid the squaring. So 5 squared was 25. So the square root of 25 was 5. Back to where we started. So let's look at another example. 10 squared I know is 100. So I would say that the square root of 100 is 10. It's that number that when I multiply it by itself, I get the 100. Here's a fancy one. 1 squared. I know that 1 times 1 equals 1. So if I undo that, the square root of 1 happens to be 1. That's kind of a bit of an odd one, I know. But if you have a look, what number multiplied by itself gives me 1? That's 1. Here's some I'd like you to go through, and yeah, maybe in your workbook or something you could fill out this little table. Just the numbers 1 through to 10, we're going to square them. So you can see I've done, let's say, the number 2. 2 squared equals 4. And then I'm going to undo it. So the square root of 4 equals 2. It's that number that we started with. If you want to go through that table, fill it in. Hopefully that gives you a bit of an introduction to what a square number is and what it means to square root a number. Well done.